Welcome back, guys, to our third video lesson for this chapter. We're going to talk today about how to solve polynomials in what's called factor forms. So we're going to talk about solving today. So let's jump right into it. All right, first of all, let's talk about what does it mean to actually solve. When I say the word solve an equation, what does that mean? Well, we'll think back to very early in the year when we talked about solving just regular equations. For example, if I said 3x minus 6 equals 0 and I asked you to solve for x, what does that mean? Well, again, when we solve for something, what we're trying to do is find a value that x represents that would make this equation true. So in this case, when we'd solve, we want to get x by itself. So here I'd add 6 to the other side, divide by 3, and then I get x equals 2. So what that means is that this x, value of 2, is a solution because when I plug 2 back into the original equation, notice here that I get 6 minus 6, and that certainly does equal 0. So it's a value that represents what would make the equation true. So what we're going to do today is talk about what is a solution to a polynomial equation, which is a little bit different. Take, for example, a second degree polynomial. If I look at like x squared plus 3x equals 0, how the heck do I solve for x? Now, one issue here is you cannot solve for x just how we normally would do it before. I can't combine these two things because I have an x squared and an x. They're not like terms. I can't just divide by an x and get rid of an x here, so there's got to be a different way I can do it. That's what we're going to talk about today. Now, what we're going to talk about today is looking at something called factor form. Okay, so we're going to solve polynomials through factored form. Now, we'll talk about what factors mean in just a second, okay, but we're going to use basically this property. It's known as the zero product property, which is very simple to understand and very important when it comes to this form of polynomial equations. Basically, zero product property means product, you can think, is multiplication, and we're going to look at what happens when you multiply two things and you get 0. So take this example here. If I have a times b, where a and b could be numbers, a and b could be a variable, if I multiply two things together and get 0, what does that mean? Well, here's the thing. If I take, for example, 3 times a number and I get 0, what does that number have to be? Well, that has to be 0. What if I take some number times x, a variable, and I get 0? What does that number have to be? Again, has to be 0. Why? Because anytime you multiply two things together and you get 0, one of those two things must be equal to 0. So if I have a times b and I get 0 as a result, then I know one of two things. One, I know that a could be equal to 0, whatever a is, number or variable. And second thing is I can say b could be equal to 0. So there's one of two options that could happen. This is known as the zero product property. What we're going to do is apply this property on how to solve equations. So let's take a look at some equations. Okay, so first of all, let's talk about what does factored form mean. Factored form means when I take a number such as 12 and I say, what are factors of 12? Basically, factors are two numbers that multiply together to give you that larger number. So here, 3 and 4, when you multiply them, you get 12. 3 and 4 are what are called factors. Okay, so factors is when you're multiplying two things. When you actually have a multiplication problem, the two things you're multiplying are called factors. So let's say I take two polynomial expressions. So x minus 6, x plus 5. So I have two binomials, remember that term binomials, that I'm multiplying together. Okay, this is called factored form because I'm multiplying two different things. Notice here that I'm multiplying this times this and I get 0. My goal is to figure out what is x going to be. What does x have to be when I subtract 6 from it and add 5 to the same number, or maybe a different number, and I get 0. Okay? So let's take a look. Well, this is where I'm going to apply the zero product property. If I'm multiplying this, which you can consider a, and this, which is b, and I'm multiplying a times b and I get 0, there's two options. Either a is equal to 0 or b is equal to 0. So what am I going to do in this case is I'm going to take each factor, x minus 6, and I'm going to set that equal to 0. And then I'm going to take x plus 5 and set that equal to 0. Okay, and what I'm going to do then is I'm going to solve each one. So I'm going to solve each equation. Here I'm going to add 6 to the other side, and I get x equals 6. And here I'm going to subtract 5 to the other side to get x by itself. Again, those are going to cancel, and I get x equals negative 5. So how many solutions do I get here? I got x equals negative 5, x equals 6. What does that mean? Well, this 6 is going to make, if I plug it in here, 6 minus 6, that'd be 0. Okay, so that's going to make this entire equation 0, which is what I want. Negative 5, I plug that in here, negative 5 plus 5 is also going to make this thing 0, which in the end result would make this 0. Okay, so how many solutions do I get? Okay, I get 2 solutions. Now over here you can see, what do we call these? Okay? Solutions to these polynomials are what are called zeros. They're called the zeros of the function because they're numbers that make the equation equal to 0. Makes sense, doesn't it? A 0 makes the equation 0. Okay? That doesn't mean that the value is 0, but they're a number that makes the equation 0. Okay? They're also known as roots, and we'll talk about that later on in this semester, so that's called a root. Okay, let's do the second examples. Here I have b minus 3/4 equals 0, or sorry, b minus 3/4 times 4b plus 5 equals 0. So again, same idea up here. I'm going to take and say the first one is a, the second one is b. They're multiplied together to give you 0. So I know I'm going to set a equal to 0, and I'm going to set b equal to 0. So that means I have b minus 3/4 equals 0, and I have 4b plus 5 equals 0. And what I'm going to do is solve each equation. Okay, so the left one I have b plus minus 3/4, so I'm going to add 3/4. Who cares if it's a fraction? I'm going to add that to the other side. That's going to tell me b is equal to 3/4. That's my answer there, so I got one solution. And then over here I'm going to subtract 5 first to the other side. Okay, then I have 4b equals negative 5. Last thing I'm going to do is divide by 4. Okay, what that's going to give me then, negative 5/4, I can't divide that out, so I'm just going to leave it as a fraction as negative 5/4, and that's going to be my second answer. So again, these are what we call the zeros of this equation because, again, these are two numbers that make this equation, no matter what, if this was b or this was b, going to make it equal to 0. All right, the next thing we're going to talk about is what if I give you a polynomial function that is not written in factored form, meaning if I look at this kind of diagram right here, this is factored form because I have 3x times 2x minus 4. So right here, this is factored form. Okay, so what if I give you something like this, 6x squared, or to the second power, minus 12x? This is not in factored form, but what we call standard form. So let me write that down for you. Okay, let me zoom in a little bit. Okay, up here, this right here, the first one on the left side, this is what's called factored form. Okay, and this is what's called standard form, what we learned about in the first section. So what if I give you in standard form and you need to factor it? Okay. Now, this is kind of a flow chart. So if you got to think, well, how do I get from factored form to standard form? When I go this route, when I go from here to here, think about what you'd have to do. You'd have to distribute the 3x to each term, like we talked about, multiplying. So here I would have to multiply those two polynomials together to get the standard form. So if I'm multiplying to get the standard form, how do I go back from standard form to factored form? Well, instead of multiplying, I'm going to do what's called factoring. Okay, I'm going to factor that standard form equation to get it into two factors. So you're going to multiply to get the standard form, factor to get to factored form. Okay? Now, how the heck do I factor something out? Well, you learned about something a while back, okay, which is called a greatest common factor. So the first method I'm going to show you today on how to factor an equation in standard form is to take out what's called a greatest common factor. So let me talk real quick about a simple example. So let's take two numbers, 6 and 18. Okay, those are two numbers. Let's say I want to find the greatest common factor between those two numbers. So here I think 1 and 6 would be factors. 2 and 3 would be factors of 6. What are factors of 18? 1 and 18, 2 and 9, 3 and 6, and that's about it. So if I look at my factors, first of all, what are factors in common? So I see I have 1s in common, 2s in common, 3s in common, 6 in common. Okay, so I have these common factors of 1, 2, 3, and 6. Now the question is, what's the greatest common factor? The GCF between those two numbers would be 6. Okay, so when I find a greatest common factor, I'm going to look at what is the greatest factor that these two things have in common. Two numbers. Okay, I can also do the same thing with variables, and I'll talk about that in a second. So let's take a look at this first example. Here I have a polynomial with 15x and 20y. Okay, what I want to do is factor this polynomial. What I'm going to do is take out a greatest common factor. So let's talk first, what is the greatest common factor? So if I look at the numbers, I have 15 and 20. So if you want to write the factors on the side, I have 1 and 15, 2 and nothing goes in 2, so I go 3 and 5. All right, that's it. 1 and 20, 2 and 10, 4 and 5. And that should be it there. Now we look at common factors. I obviously have 1. Okay, think every number is going to have 1 in common, so I'm not going to worry about that. And then I have 5. So what's my greatest common factor? My GCF here is going to be 5. So that means in these two things, I'm going to take out a 5 from each of these. Okay, So I'm going to look at this. Okay, 5, if I pull out a 5 from 15x, if I take out a 5, what's left behind? So here's what you got to think about. 5 times what would give me 15x? What would need to go in that blank? Well, I know numbers-wise, 5 and 3 must go in that blank, and then also an x, because it's going to be a 15x. So I know that in here, when I take out a 5, when I factor that out, there's going to be a 3x left behind. Okay, now let's think of the 20. 5 times what would give me 20y? All right, so again, 5 times what would give me 20. If we look over here, again, another way to look at it is look at your factors. Well, 4 times 5 gives you 20, and then don't forget we also have that y. So this up here would be left as 4y. Okay, and what I've done is I've taken out a greatest common factor, so this right here is written in factored form. That's taking that, pulling out a greatest common factor and writing it in factored form. Okay, let's take a look at the second one. Now this one example we have a little difficult here because we have both a number and a variable. So let's look. So when we treat something like this, notice how we have y squared and y. So I'm going to talk about the variable second, but let's talk about numbers first. I have 21 and I have 12. Okay, so let's look at the factors. I have 1 and 21, 2 and nothing, 3 and 7, and that's it. So we'll look at 12, 1 and 12, 2 and 6, 3 and 4. Okay, so let's look at common factors. Obviously I have 1, but my common factor is 3. That means my GCF between those two numbers is going to be 3. So what I can do is factor out a 3. So I take out the 3. Now I want you to think, what would be left behind? Okay, what would be left behind is I have 3 times what would give me 12 squared. I'm going to have 4. Look at my factors here. 3 times 4 would give me 12, so I'm going to have a 4, and I'm going to keep the y squared minus 21. Well, 3 times what gives me 21? That means I'm going to have 7 left behind. So I've now factored out a 3. However, I want you to think about this. Think about our variables here, y squared and y. Okay, we can also factor out a variable. Here's what I have. Y squared and y. What does that mean? Let's break these into factors. Well, y squared means y times y. Y simply means y. So if you look at these two, think, what is a common factor between y squared and y? Well, notice each of these have a y in common. So just like a number, what I can do is I can take out, if they have this in common, I can factor out a y. So instead of not just a 3, I'm going to factor out a y as well. Now what's left behind? Well, I know I have a 4, and I know I have the minus 7. But what goes in the blank? Okay? So you got to think, if I have y squared here, if I factor out a y times what would give me y squared? Well, it would be y times y, so I'm going to have a y left behind. Okay? And then here, if I factor out the y times what would give me y? Well, that would be a 1. Okay, so I'm just going to leave the 7 there. So what I did is I pulled out the y as well, and what I get is this as a factored form. Okay, so I took out not only a number, but a variable. So I factored both those out, drew them out, what's in common between both the numbers and the variables. And this is writing it in factored form. All right, now let's kind of tie everything together. So we talked about solving using the zero product property, and we also talked now about factoring when it's written in standard form. So now let's combine the two. So let's go back to this original. I kind of gave you equations similar to this in the very beginning of this lesson. How do I solve this? I cannot combine these two things because they're not like terms. I have a binomial here of the second degree with x squared and x. I can't combine these, they're not like terms. So how the heck do I solve this? So what we're going to do is we are going to solve by factoring. So we're going to factor this expression first, and then we're going to solve. Hey, notice here I spelt that wrong. We're going to solve this instead of solving, okay? So, all right, first of all, I have these two terms. I have 10x squared and 15x. So what we're going to try and do is think about what are factors. Okay, now I kind of did it separate in the last examples, but let's think about what are factors of 10x squared and 15x. So looking at the numbers, I have 1 and 10, 2 and 5, okay? And then I have x and x. So I'm going to write that out, okay? 15x, I have 1 and 15, 3 and 5, and then just an x. So let's think, numbers and variables, what do they have in common? So I know at least I can see they have a 5. So numbers-wise, I can take out a 5 because that's the greatest common factor there. And then they at least have an x. Okay, so they share both a 5 and an x. So what I'm going to do is in this equation is I'm going to factor out a 5x. I'm going to take out the greatest common factor. And let's think about what's left behind. Okay, numbers-wise, 10x squared. If I took out a 5 times what would give me 10? Okay, that's a 2. Okay, then the x's. X times what would give me x squared? So I'm looking here. That's going to give me an x. Okay, look at what's left behind. I have just an x there. All right, and then now the 15. I take out a 5 from the 15. So 5 times what gives me 15? That's going to be 3. Notice how I kept the negative sign too. And then I took away an x from an x. I took out my only x, so what's left behind is nothing in terms of x. So I have that. Now, what do I do from here? I factored it. I'm not done. Now I'm going to solve. Okay, so here I'm going to use the zero product property. This is A, this is B. I'm multiplying them together to get 0. So what I'm going to do is set A equal to 0 and B equal to 0. So I'm going to have 5x equals 0 and 2x minus 3 equals 0. And I'm going to solve each separately. Okay, so the left one, 5x equals 0. You might think, what does that mean, 5x equals 0? Well, if I divide by 5, what's 0 divided by 5? That's 0. That's my answer there. And then 2x minus 3 equals 0. I get 2x. I'm going to bring the 3 over, so I'm going to add 3 to this side. I'm sorry, I should have done that first. So I get 2x equals 3. Then I'm going to divide by 2 on each side, and I get x equals 3 over 2, and that's my second answer. Again, I'm not going to simplify 3 divided by 2. I'm not going to freak out because it's a fraction. And here I got 2 answers. 2 factors, 2 answers. Okay, so I solved by factoring. Okay, so let's take a peek at the second example. Here's what I want you to do. I want you first, okay, take a look at this equation. What's different from this one than what we just done? Okay, so first of all, you notice you have 6w squared equals 12w. So my equal sign is in the middle. Notice in the previous example, it's equal to 0. So I want to think ahead of time. If I'm going to use the zero product property, if I want A times B equals 0, well, what I'm going to do is first, I'm going to take my equation and set it equal to 0. So I'm going to make this equation say one side equals 0. So I want equals 0. So how do I do that? Well, simply, I'm just going to take 12w. To make it equal 0, I'm going to subtract it and bring it over. So I'm going to have 6w squared minus 12w. I cannot subtract 12 from 6. I cannot combine the w because they're not like terms. All I did was move this to the other side. And now what do I have? It's equal to 0. That's important because we cannot apply this property if it's not equal to 0. So what I'm going to do is factor. Okay, so quickly I want you to think, pause the video right here. What would be my factor of 6w squared and 12w? And I want you to take that out and see what you get when you factor it. Pause it. Go. All right, so take a look. Here's what you should have had. I have here, wrote down my factors. 6w is my greatest common factor looking at numbers and variables. So what I did is I factored out the 6w. I thought 6w, when I bring that out here, what's left behind? Well, really the w squared, I am left with just a w. Okay, 12w, I took out a 6, so 6 times 2 would give me 12. W times 1 would give me w, so I took out the only w, I have that. So now the next step is you're going to solve using the zero product property. So again, this A, that's B, you're multiplying them together to get 0. So I'm going to apply this property. I'm going to take A equals 0 and B equals 0. So A equals 0, that's 6w equals 0. B equals 0, that's w minus 2 equals 0. I'm going to solve each separately. So I'm going to divide by 6. Divide by 6, I get w equals 0. 0 divided by 6 is still 0. Okay, then I'm going to add 2. W then is going to equal 2. So I get my two answers of 0 and 2. So again, solving by factoring. Key thing here that I said, make sure our equation equals 0. So you might want to write that, jot that note down for yourself. All right, I have some problems for you to try, so let's see if you can do those. So first of all, the first example, all I want you to do there is factor, but here notice you have 3 terms. Treat it the same way. Find the greatest common factor of numbers and variables between the 3 terms. And the second one, I want you to solve. 9y squared equals 15y. Again, think about the last example we just did. All right, pause the video, give those a whirl. Ready, set, go. Okay, a lot of meat and potatoes here. Let's take a look at the first example. So I took all 3 terms, right here, here, and I wrote out all the factors. Okay, the first one's kind of confusing. 2g to the 4th. I took the 2. 1 times 2 is the only factor of 2. G to the 4th, what does that mean? Think of exponents. G times D times D times D, 4 g's. Okay? So that was the only trick there. You had to think there's 4 g's multiplied together. Okay? Then you have 14g squared. I did 1 and 14, 2 and 7, g and g. 6g, I did 1 and 6, 2 and 3, and then a g. Now look, numbers and variables, all of these have a 2 in common. So 2 is the greatest common factor in terms of the number, and they all have a g in common. So I factored out then, greatest common factor is 2g. So I took 2g out of the equation, what's left behind? Well, from this, okay, this one's a little tricky because I took out a 2 and I have a negative 2. So when I factor out a 2, 2 times what would give me negative 2? Here notice I have a negative 1. Then I had 4 g's, I took out 1, there's 3 behind g to the third. Okay, then 2 times what would give me 14? That'd be 7. So factored out 2, get a 7. Factored out a g, there's 2 g's. I took out 1, there's 1 left behind. Then 6, 3 times 2 would give you 6. Factored out the only g, so it'd just be 3 by itself. Okay, a little tricky there. Next example. All right, I have 9y squared equals 15. So this one I did a little step by step. Again, I want my zero product property, so I need this equation equals 0. So what I did first was subtracted 15y over here to get 9y squared minus 15y. Okay, factored both of these. I got my factor, greatest common factor of 3y. So I took 3y out of the equation, and then what's left? 3 times 3 would give me 9. Y times y would give me y squared. 3 times 5 would give me 15. Y times 1, factored out the only y, there's nothing left behind. So I get these two factors equal to 0. Then I applied the zero product property. This is A, that's B, equals to 0. So I took A equals 0 here, got y equals 0. Dividing by 3 doesn't do anything. And then I took 3y minus 5. I added the 5 first, then divided by 3, and I get 5/3. So again, there's my 2 answers. Okay, so a lot of interesting things going on in this lesson. What we talked about, again, is how to factor and then how to solve through factoring. Make sure if you have questions, you jot them down. Please jot down any questions or where you have confusion we could talk about in class. We'll see you next time, folks.